Good morning, everyone. I hope you're behaving well for Mr. Kanji. Take out something to write with. We're going to try to do this without a calculator, just like yesterday. Let's try to do this without a calculator. We're going to look at the vertex form of a quadratic today. Okay, so let's get going on this. We're going to look at the vertex form. The retake is Thursday after school. I'm still holding that if you're still going to be here, and a test on quadratics next week. Okay, so I'm going to read some of this to you. You have it on your page. As you know, a function in the form y equals ax squared plus bx plus c is what we call a quadratic. Okay, we're going to look at quadratic functions today. So in the first one that you have, y equals x squared plus 2x minus 1, you can see that this is the vertex right here. Okay, and you can notice that the vertex is at coordinates -1, -2. It's a turning point. It's a minimum. You can see that it opens up because a is positive. Okay, and the other one you can see we have a is a positive number also, so it's opening up. You can see the vertex does not fall at exact values. You can see though the y-intercept is at 0, 2. Okay, and the other one, the third one, you can see now our parabola is opening down because a is a negative number, -2. Again, you can see the y-intercept is at 0, 3. So these are just some things that you should notice about these. So each of these graphs has a curved shape known as a parabola. You're used to that word. Each graph, sorry, also has a minimum or a maximum called the vertex. Okay. If you look at the coefficient of the x squared, if it's positive, then the parabola will open up. So when a is greater than 0, it opens up. When a is less than 0, it opens down. This I think you know from last year, but just reiterating it. Okay. Parabolas and all functions have y-intercepts at a point that looks like 0, comma y. Okay, so we can find this y-intercept by substituting. I wrote y in for x, but this should be saying 0 in for x and solve for y. So plug in x equals 0 to find the y-intercept if you can't see it in a graph. Okay. You should know that there's an axis of symmetry for each of these graphs, okay, and you should be comfortable finding that axis of symmetry, possibly using x equals -b over 2a. It's where your graph is symmetric. So you should feel comfortable knowing that if you know your vertex, that each of your solutions will be an equidistant. So if this is 2 away, then this would be 2 away or something like that. In that graph, it's not exactly 2. Okay, so you can fold your graphs in half. Okay, so if you flip your notes over, there is this video that I want you to watch. So I'm going to play it for you now. So you can remember what we did about translations here, that when you do x minus h, it actually moves it to the right. So even though it's a minus h, you're moving to the right. Okay, so that should just remind you about what we did with transformation. So it's also written here, some of the basics. So A is a stretch, okay? The x minus h is going to shift the graph left or right. So if it's a positive number, it's going to go to the left. If it's a negative number, to the right. And the plus k is what's going to shift the graph up or down. If it's a positive number, it's going up. If it's a negative number, it's going down. So let's just look at a couple of these. These are what we call vertex form of a parabola. And so instead of writing y equals ax squared plus bx plus c, we write it in this uh, different form. It kind of looks like we completed the square, and that's how we find it. So the vertex of this one is actually 2 comma negative 1. So again, you're taking the opposite of whatever the x value is. So here it's negative 1 comma negative 4, and here the vertex is 3 comma 2. So you negate whatever the x value is. You can see if they open up or down. You can see the vertices here. Okay, so what we're going to do, again, we know our axis of symmetry. We know our roots or our solutions, one away, one away. So this is a symmetric graph. So for quadratic functions of the form y equals a times the quantity x minus h squared plus k, the vertex is at whatever the h is, and the k, the h that we negate. So this is right now a minus h, and here it's a plus h. So it's always going to be opposite signs. Okay. All right, so here we go. Write the equation of y equals x squared minus x minus 4 in the form. This is what we call vertex form. So this is like completing the square. So that's what we're going to do. Following our steps to complete the square, I'm going to start by moving the 4 to the other side. So I have y minus 4, and I'm going to leave some place because I know I'm going to add something here, equals x squared minus 6x. So now I need to say, okay, minus 6 over 2 squared. No calculator here. So minus 6 over 2, I get negative 3. Squared is 9. So that's what I'm going to be adding to both sides here. I'm going to say plus 9 on this side, plus 9 on this side. So then when I actually complete the square, here I have y plus 5 equals x minus 3 squared. And if I subtract 5 from both sides, I have y equals x minus 3 squared minus 5. And so that is vertex form. So now I know that my vertex is going to be 3 comma negative 5. I can find my y-intercept by plugging in x equals 0. So if I plug in x equals 0, I get y equals 0 minus 3 squared minus 5. So negative 3 squared is 9. 9 minus 5 tells me my y-intercept is 4. So if I'm going to sketch this labeling the vertex and the y-intercept, I need some axes. This is just a sketch. Okay, I know my vertex is going to be at 3, negative 5. 1, 2, 3, negative 5. 1, 2, 3, 4, 5. So 3, negative 5 is my vertex, and I know my y-intercept is up at 4. 1, 2, 3, 4. So trying to draw a parabola as best you can, it would go through 4, and it would have a vertex at 3, negative 5. Okay, so we're going to try another one like this, writing it in vertex form by completing the square, following the steps that you know from last week. So in this one, write the function in vertex form. So unfortunately here we have a 2. So I'm still going to start by moving the 11 over. So I get y minus 11 equals 2x squared plus 8x. So I need to start by getting rid of that 2. So I'm going to divide everything by 2. I understand that we still have fractions in some places, and that's okay. So here I have y over 2 minus 11 over 2 plus something is going to equal x squared plus 4x plus something. So I need to complete my square here. So I'm going to say, okay, what is 4 over 2 quantity squared? 4 over 2 is 2, 2 squared is 4. So that's what I'm adding to both sides to complete the square. So on the right-hand side, I have x plus 2 quantity squared. On the left-hand side, though, I have y over 2, and then I need to combine these. So 11 over 2. So how do I write 4 as a fraction in terms of 2? 4 is the same as saying 8 over 2. So now I can add these two values. So negative 11 over 2 plus 8 over 2 gives me minus 3 over 2. So I would get y over 2 equals x plus 2 quantity squared plus 3 over 2. I know there's fractions. And then to get y by itself, I would multiply both sides of my equation by 2. So I'm going to distribute this 2 to both. So I end up with, I know this is getting a little bit messy, but y equals 2 times the quantity, x plus 2 squared. And then when I do 2 times 3 over 2, I just get plus 3. That is the the quadratic in vertex form. So I completed the square, and even though we had this wacky dividing by 2, we just undid it by multiplying by 2 at the end. If I were to sketch this, my vertex would be at -2, comma 3. Okay, and to get the y-intercept, I would plug in 0. So I would get 2 times 0 plus 2 squared plus 3. I'm just using the equation over here. And I would get 11. So my y-intercept would be 0, comma 11. So if I were to sketch this again, x and y axes, I know my y-intercept is up at 11, and then my vertex is at -2, positive 3. So that's got to be maybe around here, if 11's up there. So that's my vertex. So it has to look something like that, but it has to look like our function f of x. So another type of form that we're going to look at besides this vertex form where you complete the square is what we call factorized form. So factorized form means it looks like you have factors. Your factors written out. Okay. So each of these graphs are written in factored form. So these are your factors up top. So we have x plus 3 times x minus 1, and then your roots, or your solutions, which is also called your zeros, which on your pre-assessment you guys are a little bit worried about, are then take these values and actually solve them to see what does x equal. So you can see them there. So if your roots are if your roots are -1, then your factor is going to be x plus 1. If your root is +4, then your factor is going to be x minus 4. So if you flip your page, we have this example of writing the function in this factored form. So you're going to think of what numbers multiply to -10 but add to 3, and I bet you already thought of them. So I know f of x equals x, and you should be thinking -5 and x plus 2. You're not solving here because we don't have it equal to 0. And if we were to actually sketch this, sorry about that, if we were to sketch this, I would have my axes. And I would say, okay, my solutions, if I do solve it, would be x equals 5 and x equals -2. So then I would graph -2. I would graph +5. I know the y-intercept is going to be what happens when I plug in 0. So 0 minus 5 times 0 plus 2. So I get -5 times a +2 is a -10. So that means my y-intercept is down at -10. So my parabola needs to go something like that. I know my vertex needs to be between -2 and 5 because this is a symmetric graph. So -10 is not the vertex. Okay, what does this look like in an exam style question? This is a good one. So f of x equals x minus p times x minus q. Write down the values of p and q. If you notice, they tell you the solutions here are 2 and -1/2. So if I were to write the factors, it would be x plus 1/2, and it would be x minus 2. So if I'm trying to think of what p and q are when they write it like this, my p would be -1/2 because they're saying minus p. So that's actually going to be a -1/2. And then q would equal, since they're saying minus q here and we have minus, our q would just be 2. The function has a minimum value at the point C. Find the x-coordinate of C. Okay, so the minimum I know is right here, and I know that the minimum falls on the axis of symmetry. It's halfway between these two. So you can figure out the halfway between 2 and -1/2. If you figure out that halfway part, it's actually at x equals 1.25. So that's going to be the x coordinate. Okay, I'm going to do one more with you before I let you practice. So write the function in factorized form. So when I see this one, I'm thinking AC method. So if I do AC method, a times c is 2 times negative 3, it's negative 6. So I get 2x squared, and then what multiplies to negative 6 and adds to negative 1? Plus 2x minus 3x minus 3. If I factor now by grouping, I can pull out a 2x, x plus 1, minus a 3 times x plus 1. So my factors are 2x minus 3 and x plus 1. I just did AC method. They want it in this form though, and we don't really have that a out in front. So if I pull this 2 out, if I divide this by 2 and this by 2, so I now have 2 times, I'd be left with x minus, okay, no calculator again, 3 over 2, times x plus 1. That would be it. This would be our f of x equation. Yes, there's a factor, but that's okay. So sketching this graph, then you need to think about, okay, what would be my zeros and my y-intercept? So the solutions, if I set my equation equal to 0, would be x equals negative 1. Okay, and if I set this part equal to 0, I would get x equals 3 over 2, which is the same as 1/2. If I wanted to find my y-intercept, I would plug in 0, and I would get 0, comma, negative 3. So then I'm going to sketch this, x and y axes. Negative 3 is my y-intercept, negative 1, and then not quite 1, not quite 2, that's my other x-intercept. Okay, so if I'm connecting these, I know my vertex is going to be somewhere over here. I don't know what it is. Okay. So for the rest of this, please complete the practice. You can work together, and if you have any questions, I will see you on Thursday.